So this is a question that in class I called the Cheerios problem because the cereal was Cheerios. If there are prizes distributed as 1 in every n boxes of cereal, and I purchase n boxes of cereal, what's the probability that I win something, or what's the probability that I win nothing? So let's just look at this. First of all, if I buy n equals 1 boxes, n equals 1 boxes, and that's 100%, or we write that as a probability of 1. So the percent symbol means literally divide by 100. Okay, so if 100 divided by 100 is 1, right? So that's where I get the 1 value. Okay, what happens if I have n equals 2 boxes? And it starts to get more interesting. And then you have a 50% chance of getting something or nothing on every box. So it's much easier to calculate I win nothing than I win something. So let's calculate win nothing and then say 1 minus that. So it's 50% or 1/2 chance that you win nothing on the first box, and 1/2 chance that you win nothing on the next box is 1 over 4 chance of nothing. So you have a 3 in 4 chance of winning. This is the same way of saying if somebody's going to have 2 kids, what's the chance that the person is going to have 2 boys in a row, for example, no daughters. Next one, n equals 3 boxes. And in this case, the chance that your first box, so chance of winning nothing, I've got it written there. Chance of winning nothing, well, mostly you're going to win nothing on each round, but if you do it 3 times, it changes things a bit, right? So what is this probability? Okay, let's say we have 2 divided by 3, and then we raise it to the power of 3, and so we're talking about 30%, okay? Or 0.3. Okay, so that's your chance of winning nothing, and your chance of winning is 1 minus this value, or it's approximately 0.7. All right, so let's go up to 4 boxes. It's going to be 75% chance of nothing each time, 4 times. Okay, so it's 0.75 to the power of 4, and it's about 0.32, let's say. And this value is about 0.68. Okay, so generically, let's try n just being n boxes. Okay, so the numerator of this fraction is n minus 1 and the denominator is n. That's a probability of getting nothing to the power of n is chance of nothing. And 1 minus this value is the chance of winning. Here you go. And this is the thing, you want to either this one or this one. Take the limit as n goes to infinity. Okay? So what's happening is really, Theodore? What is this? Well, first of all, this doesn't have to be inside the limit at all. Theodore, stop. Okay, this is 1 minus 1 over n to the n, because this is just algebra, right? So if I pull this aside, n minus 1 over n is just n over n minus 1 over n, which is just 1 minus 1 over n. Okay, so I don't know if that tricked anybody. I wasn't meant to. But that was just a little bit of algebra. Okay. And let's see, what else do we need to explain? I guess we're good to go. If I just do this, I told you guys in class that this little calculator here is really awful at this. I could use Wolfram Alpha, I guess. I could say 1 minus 1 over 100. That's just 0.99. Okay, then to the power of, and then it was 100, right? And so it's just saying 0.366 is, so your percent chance of not winning anything is about 37%. Okay? It turns out that note, and this is a side note, but so it's an explanation. So this is the piece I put in a box in class and said, you do not need to know this. I will provide this if you need it on a problem. It's equal to e to the r. So this is the piece that I don't expect you to memorize, but if I give it to you, you could use it. So note, since this is true, then I could let r be -1. Which is what I have, which is 1 over e. Okay? And it does indeed come out to be 1 minus 1 over e. And then that's going to be 1 minus 1 divided by e. 0.6321. So you have about a 63% chance to win for reasonably large values of n. And the surprising part was that, reasonably large, it might even be 5 or 6. So for any game is probably a pretty good estimation, because they're not going to give you like 1 in 3 boxes is going to have a prize. That's never going to happen, right? So it'll be like 1 in 10 or 1 in 20 at the best. So it's a pretty good estimate.